Now today's lesson, I will talking about the alternating currents of principle. AC current principle. So AC current is generated by the generator. The normally there are the two people here, and between pole there are the current carrying conductors. So the electrical current is a magnetic flux are passing through from the pole to pole, and under the influence of the magnetic flux, when the conductor is rotate, then the voltage will be induced. This voltage is an alternating current. Alternating current. So this current is changing from the die to die. So this one is changing from the die to die. This is AC waveform. AC waveform is changing with the die. So here will be the die is a horizontal is a die, vertical is a voltage. So this horizontal die and vertical volt. So this voltage reach the maximum, then go to 0, and then go to the negative maximum, and then go to the 0 again. So the 0 here, 180 and then 360 degree. So this 0 to 360 degree we call the one period. Period can be calculated. Period T equal to 1 divided by frequency. Or the frequency 1 divided by time period. So frequency can be calculated 1 divided by period. Or the frequency here unit is a hertz. Is represented by the F is divided by 1 by T. F unit hertz, T unit is a second. So this is the way we calculate the frequency of the AC waveform. So this AC waveform, here is a maximum value. So this is a waveform here. This is a maximum value. This one is P to V value. So the P to V value is 2 times V maximum. 2 times maximum value, this is the P to V value. And we also calculate the RMS, VRMS. VRMS is root mean square. Root mean square is in our home. You got a 230 volt supply. In this case, this is a root mean square value. So root mean square value VRMS can be calculated. V maximum divided by root 2. V maximum is 1 by 4142. So the V maximum divided by the root 2 is a 1 by 4142. So the V maximum divided by root 2 or V maximum divided by 1 by 4142. We can calculate the VRMS. So this is V maximum divided by 1 by 4142. So RMS value is maximum voltage divided by 1 by 4142. We also calculate average value. V average value is a V maximum multiply 0.637. So V maximum multiply 0.637, we can calculate the average value. The next one will be that the ratio of the RMS and average value is a form factor. Form factor VRMS divided by V average. So for the sinusoidal waveform, form factor is ever 1.11. So form factor is 1.11 for the sinusoidal waveform. So this is the way we calculate the form factor, VRMS, and the size for the AC waveform. And then when the waveform is rotating, so this is a generator is rotating. So the from die to die is a generator here. This angle is theta. So rotating at the phase angle theta. So that at a certain time, we can also calculate the value. This is we call this V instantaneous value. V instantaneous value can be calculated. This is a VINST. This is a V maximum sine theta. So instantaneous value is maximum value multiplied sine theta. So this is the instantaneous value we can calculate it. So those are the properties of the AC waveform. Now we saw the one problem. Voltage V maxima is given 340 volt. Angle theta is given at 45 degree. We need to calculate the V instantaneous value. V instantaneous value can be calculated V maxima sin theta. V maxima sin theta, we can calculate the V instantaneous. Therefore, the V instantaneous at the 45 degree is maximum value is 340 and sin 45. Then we can calculate this voltage, that will be the 240 volt. So V instantaneous value is 240 volt. This is for the problem, this problem. Another one is another problem. V maxima is given 500 volt. So we need to calculate VRMS. Or we also need to calculate VP to P. VRMS, P to P we need to calculate. Also we need to calculate V average. VRMS need to calculate. P to P need to calculate. Average need to calculate. So in this case, we calculate. Firstly, VRMS equal to V maxima divided by root 2. So maximum value is 500 volt. Root 2 is a 1.4142. Therefore, RMS value is 353.6. So this is the RMS value 353.6 we can calculate. Also, we can also calculate VP to P. VP to P is a 2 times V maxima. So in this case, our V maxima is 500 multiplied 2, so you got there 1000 volt. P to V value is 1000 volt we can calculate. We also need to calculate V average. So according to the formula, V average is V maxima multiplied 0.637. Therefore, the maximum value is 500 multiplied 0.637. So we got 318.5 volt. So this is for the answer for the problem. So these problems are given the maximum value 500 volt. We need to calculate RMS value. We need to calculate the P to V value, and we need to calculate V average. So that we write down the equation. Maximum voltage is RMS value is a maximum divided by root 2. So the 500 maximum divided by root 2, 1.4142, you got a 353.6 volt. Also, VP to V need to calculate. VP to V is a 2 times V maximum. 2 times V maximum 500, you got a 1000 volt. V average need to calculate. In this case, the V maximum multiplied by 0.637, average value is 318.5 volt. So this is the way V maximum, VP to V, VRMS we can calculate. The next one is that we also need to calculate the frequency. Need to calculate the frequency. So this problem given at the 0.202 second. Waveform travel at the 0.032 second. We need to calculate the frequency. So this 0.02 second is a period. This is 0.02. Frequency can be calculated 1 by t. So 1 divided by 0.02, you got the 50 hertz. So this is the problem. Time taken to travel is a 0.02 second. We have to calculate frequency. In this case, this t is a 0.02. So frequency can be calculated 1 by t. So the 1 by 0.02, you got the 50 hertz. So this is the way we calculate the frequency. Frequency is 50 hertz. Another thing is that we can measure the AC waveform by using the cathode ray oscilloscope. So cathode ray oscilloscope is a device on which you can see the AC waveform as well as you can measure the frequency. So that how we do is a cathode ray oscilloscope consists of this is scale here. They call this a division, vertical and the horizontal division. Vertical division, we can measure the body. Horizontal, we can measure the die. Vertical for body, horizontal for the die. So this is the cathode ray oscilloscope. So how to measure the body? In this case, we have to select the vertical scale. On the cathode ray oscilloscope, you can select the switch. That switch is a 4-bar division switch. So the 4-bar division switch, you can select 1 4-bar division or 2 4-bar division or 5 4-bar division or 10 4-bar division, you can select. And when you see the waveform here, you can count how from the horizontal how many are division. You can count. So the vertical scale voltage can be calculated 4-bar division multiply number of division. Therefore, the vertical scale is you can measure the voltage. You can select the 4-bar division on the cathode ray oscilloscope scheme. They call the switch. So you can select the switch. And you have to count how many we have horizontal line, how many division. So the number of division multiply 4-bar division, you can calculate the voltage. So this is the way you can measure the voltage. Similarly, horizontal. Horizontal, you also measure. In this case, you have to select the time bar division. Horizontal scale. Is a time. Horizontal scale, you can calculate also time bar division multiply number of division. So this is the horizontal scale time you can calculate. You can measure. Then, if you know the time, you can calculate frequency. Frequency is 1 over time. 1 divided by time. So this is the frequency. So here is frequency. So this is how to measure the voltage and the frequency of the AC waveform by using the cathode ray oscilloscope. Vertical scale, we can measure the voltage. Horizontal scale, we can measure the frequency. How to measure the voltage? In this case, you need to select the 4-bar division so that you have to count how many are from the 0 axis to the maximum P value. You have to count how many division. Number of division multiply 4-bar division, you can calculate you can measure the voltage. Also, horizontal. So you have to count here wave to here to here. This is one waveform. You have to count how many division. Number of division multiply time of division. You can calculate the T. So the 1 divided T, you can calculate the frequency. So this is the way how we measure the voltage and frequency by using the cathode ray oscilloscope. This is the way we measure. Now that we see the one problem. This problem is we measure the waveform. In this case, 2.8 division high. Also, 8 division low. So we have to measure the voltage. In this case, we can select the 4-bar division is 10 4-bar division. Switch time is 1 millisecond. So those are the we are measuring the waveform. In this case, we select the 4-bar division, 10 4-bar division. Switch time is 1 millisecond. So the voltage got the high is a 2/8 division high and 8 division low. Therefore, the 2/8 division high is this is the vertical scale here. This is a 2/8 division. Horizontal scale here. This is a 8 division. 2/8 division high, 8 division low. So we can calculate the voltage. V maximum value. Maximum value is 4-bar division multiply number of division. So 4 bar division is a 10 4 bar division, number of division 2 by 8, you got the 28 volt. Maximum value is 28 volt we calculate. So from this 28 volt, this is the maximum value. We need to calculate the RMS value. So we use a formula. VRMS equal to V maximum divided by square root of 2. So this is the RMS value equation. So V maximum value is at 28 volt here. Square root of 2 is 1.4142. So you got that value is 19.8 volt. RMS value is 19.8 volt we calculate. Similarly, we can also calculate the time. Time can be calculated. Time equation is a time bar division multiply number of division. So time bar division scale is we select the 1 millisecond. Number of division here we got the 8 division. So this is the 8 millisecond. Time is 8 millisecond. This means this waveform is traveling to complete the one cycle is traveling 8 milliseconds. So this is the 8 millisecond. Here to here is taking the 8 millisecond. So this is the T. This is the 8 millisecond. So if you calculate that, if you know the T, you can calculate the frequency. Frequency equal to F equal to 1 by T. 1 divided by time, we can calculate frequency. So then 1 divided by 8 millisecond. So 8 millisecond, 8 multiply 10 power minus 3. 10 power minus 3 go to numerator, then we 10 power 3 divided by 8. So 10 power 3 is 1000 divided by 8, so you got the 125 hertz. So this means that this by using this oscilloscope, we can measure the maximum value. Maximum voltage is at 28 volt. Then RMS value is a voltage is at 90.8 volt, and frequency is 125 hertz. This is the way we measure on this oscilloscope. Then we solve another problem. This problem given the two sine wave. They are traveling at the 50 hertz. Frequency of 50 hertz. And time difference is 3.5 milliseconds. Time difference is at 3.5 milliseconds. So therefore, there are two sine wave. Sine wave 1 and also sine wave 2. So these two sine waves are time difference is at 3.5 milliseconds. We need to calculate the phase angle. Phase angles different we have to calculate. So in this case, how we calculate? We have to know that one waveform here, one waveform is 0 to 180, 180 and go to 360. So that to travel the 360 degree, time taken is a t second. So that t second 360 degree. Time taken, so this is one period. One period is the way one will travel one period. To complete the one cycle, time taken is a t. So this one cycle is a 360 degree. So the t second is related to the 360 degree. So this is the concept. Then the waveform is 50 hertz is given. So in this case, we can calculate frequency divided by 1 by t, or t equal to 1 by frequency. So the 1 divided by frequency 50, so you got the 0.02 second or 20 millisecond. So this 20 millisecond is a 360 degree. So 20 millisecond related to 360 degree. Now 3.5 millisecond. How many? So the 360 multiplied 3.5 divided by 20. So we can calculate. This is the way we calculate his. So the 63 degree. So the phase difference is a 60 degree we can calculate. So this is the way we calculate the phase difference of the sinusoidal waveform. The next one will be I explain you about the resistor, inductor, and the capacitor. This is resistor. We connect the resistor to 240 volt. Resistor is 10 ohm. So the how much current will be flowing? So that will be I equal to 240 divided by 10. So you got the 24 ampere. For the resistor, we apply the voltage V and resistor current. Resistor current is so resistor current and the voltage are the same direction. This is the in phase. For the resistor, when you supply the resistor to the voltage, connect the resistor to the voltage, so the electrical current flowing. So that this is the AC 240 volt and resistor 10 ohms of current flowing. So the current and the voltage are same direction. This is the in phase. This is the properties of the resistor. And then for the inductor, inductor is a coil. If you connect this coil to DC way, it will be short circuit. But for the AC way, there will be some resistance in the coil. So the resistance in the coil happen. So this is the AC waveform. So this resistance of the coil can be calculated. That will be the H equal to 2 pi F. That equation. So in this case, the L is an inductance. A is an inductance. Unit is a Henry. F is a frequency. F is a frequency. Unit is a hertz. So the H can be calculated 2 by F. So the 2 multiplied pi multiplied F multiplied L. So we can calculate that. This is why H equal to inductive reactance. Unit is a O. So this is the way we calculate. So if you connect this inductor to the voltage, AC voltage, this voltage is the direction. The current is a lagging behind. So voltage coming first, current later. So this is a 90 degree lagging. So for example, you got the inductor. Inductor is a 1 Henry. So we can calculate inductive reactance H equal to 2 pi FL. 2 multiplied by 3.1416, frequency 50, inductance 1. So we got 314 ohm. So this is the inductive reactance at 314 ohm. The current flow into the inductor is 90 degree lagging. And also that we can also calculate for the capacitor. Capacitor. So this is the capacitor. If you connect the capacitor to DC, there is no current will flow. But if you connect the capacitor to AC, there will be some current flow. Because of the capacitor got the resistance, this is we got the capacitive resistance. So AC is the inductive reactance, AC is the capacitive reactance. Capacitive reactance. Unit is ohm. So the capacitive reactance AC can be calculated 1 divided by 2 by FC. As a frequency, C is a capacitor value. For example, capacitor C is a 1 microfarad. We need to calculate the capacitor reactance. So in this case, AC can be calculated 1 divided by 2 pi is a 3.1416, frequency 50, capacity 1 microfarad. 1 microfarad is 1 into 10 power minus 6. So that will be 10 power 6 divided by 314. So you got 3184 by 7. Oh, so this is the capacity reactor 3184 by 7 ohm. So that if you connect the capacitor to a voltage supply, so there will be the voltage here. The current IC is a leading. So this is a 90-degree leading. So capacitor current is 90-degree leading ahead of the voltage. Inductor current is 90-degree lagging ahead of the voltage. So this is the properties of inductor and the capacitor.